Hello everyone. In this video, let's take a look at a day trading operation and see if we can use some of our tools to calculate some probabilities and quantiles. Let's take a look at it. So it says Alex runs a solo day trading operation focused on high frequency trades of major tech stocks on the NASDAQ. Each day, Alex typically completes dozens of trades and over the past year has tracked his net daily profit closely. After compiling the data, Alex determined that his daily profits follow a normal distribution with an average of 2,000 per day and a standard deviation of 750. His goal is to build a steady track record to qualify for funding from a proprietary trading firm, which requires consistently profitable performance with minimal volatility. Alex also regularly evaluates his performance in batches, reviewing samples of daily profit across multiple weeks to understand patterns and risks better. As part of his planning, he's interested in understanding the likelihood of both high profit days and riskier low profit periods, especially when averaging performance across longer time frames. Okay, so we've been given a little bit of information. We know a few things, and we can see from up here, we have a couple of numbers that are probably going to be important. It says that, hey, we're following a normal distribution. So we kind of look over here on this part of the flow chart. We see that, hey, we're going to be working with our normal distribution, so that's handy. And they're given two numbers. They're given this 2,000 value. Let's just put this up here real quick. 2,000, and let's also put up this 750. And we need to give these some values. So these are, we can see that he's compiled his data, he's determined his daily profit, follows a normal distribution, and it has an average of 2,000. So that is going to be our population mean, or our mu. And then it gives us a standard deviation, and this is a population standard deviation, which is sigma. So we've got our mu and we've got our sigma, and we can now use this in order to start calculating our probabilities, because in order to fully define any normal distribution, we need to have a mean. Let me zoom in on this so we see our graphics. We need to have a mean, which is defining the center of our normal distribution, and we need to have a standard deviation so that we can ultimately calculate out this standard error to be able to fully define our normal distribution. Okay, so let's go ahead and keep on going. We know that we are dealing with numerical data because we've been given like an average and a standard deviation. We weren't given any counts. And so we know that we're going to be dealing with numerical. Let me scroll over just a second. There we go. We know we're going to be dealing with our numerical. And so if we use our kind of central limit theorems, we know the sampling distribution of x bar, or of our mean, is approximately normal if either the original distribution of x is normal, which we have right here, or if we've got a large sample size. So we have it's already stated that the original distribution is normal, so we are good to go for any sampling distribution of any size. If it's a sample size of 1, or if it's a sample size of 1,000 or 2,000, we know that the sampling distribution is going to be approximately normal. So if we scroll over here, we can see that when we are looking at our probabilities and our quantiles, we have some key variables that we need. We need the mean, we need the sampling mean, which is just the same thing as the original mean. We need a sample size, we need a standard deviation, and we need the standard error. So we were given the standard deviation of the original, and let's go down and look at our questions. So question 1, it says, what is the probability that Alex's net profit on a randomly selected day exceeds 3,500? Okay, so it looks like we were given a sample size right here, so we can say that n equals 1, because we're just looking at a day. So like some of these, it's handy to know, it's like, okay, how many days? We're dealing with 1 day right now. And we're looking at an x bar. I like seeing these as like an x bar. It's a sample mean of a sample size of 1. So it's just whatever observation that we saw, and that is our 3,500 that it gave us right here. So now the question is it wants to know this profitability exceeds 3,500. So if I draw just a really quick picture, let's see if I can pull this off real quick. So what we have here is we have just a very simple normal distribution, and the center is at our 2,000. So we'll do 2, 0, 0, 0. So we've got our 2,000. And then let's get another value. And we're looking like up here for this 3,500. So if we go 3,500, and it wants to know, it says, for the probability to exceed 3,500. So if we do that, we can go to our, let's go to draw, and we'll just highlight it in. And it's kind of that area going to the right. We're looking for the probability of being greater than this value. Okay, so this graphic is not scaled correctly at all, but it gives us an idea of what we're looking for. So we're looking for this area to the right. So we look at our bottom area. Oh, let's see what else that we need from our key variables. We have our population mean, we got our population standard deviation, we got our sample size, we've got our x-bar. Looks like that we missed getting our standard error. Let's just go ahead and take a moment and do the standard error. Oopsie, sorry. And that is just going to be equal to the population standard deviation divided by the square root of the sample size. And here the standard error is exactly equal to the population standard deviation. But if we keep it like this, it'll help us that when the sample size changes, all we have to do to calculate a new standard error is to just use we just update our sample size and it will change our standard error for us. So like, for example, let's say that we have a sample size of, we'll say 20 in the next problem. Notice how it updates the standard error for us. So this is really handy. It works for any sample size. And then we need to find our z-score here. Now we can use this standardize calculation to help us out, which is really handy. Standardize basically does just this z-score calculation right down here. Okay, so let's try to calculate out this probability of a randomly selected day. Let's scroll over and see that whenever we're doing probabilities, we have kind of three options. We have a less than, an area, whoopsies. Okay. We have this area to the left, we have the area to the right, or we have the area between. So we want this greater than area. We want the area to the right, and we can type this thing out. So it's the probability of like our x bar being greater than 3,500 if we write it out in a probability statement. And this is just going to be equal to norm dot, oopsies, let me type it out exactly like I've got it here for greater than, equals 1 minus norm dot dist of, we need our x bar, okay, this is our 3,500, comma, now asks us for over here the mean. We're just following this this formula here. We want the mean, and then it wants our standard error, and then we need to put in the word true, and we hit enter, and we get 0.0227, so rounded, we get 0.0228, which is fantastic. That's our value right there, letter A. All right, first one done. Let's look at the next one. Okay, what profit amount for a single day represents the 10th percentile? Okay, so let's kind of just label that real quick. We'll say the what percentage. And we can say that this is 0.10 or just our 10th percentile. And I want to know what profit amount for a single day represents the 10th percentile. Okay, so percentiles, let me kind of give you an idea on this real quick. So a percentile is saying, let's go to draw. If we shade in from the left, this is how percentiles go, shade in from the left, and I shade in to a point, it's saying, okay, at what point do we hit where we get 10%? So let's go back to my drawing. So what we don't know is this critical point on the number line. We don't know what that value is, and we want to find it. We know we want this area to be 10% shaded, and we need to know this critical point. If we look down here at the probability in quantiles, what we did the first time is we found like an area under the curve. But here we are given the area under the curve, and we want to know this critical point. And how we do that is using our quantiles. So let's go over to our quantile calculation. And we want this bottom percentage because a percentile is always starting from the left and shading until we hit whatever percentile we're looking at, in this case 10%. So let's do the cutoff for the bottom percent. So here, oops, let me get out of there. Let's go to just, sorry, home. There we go. We'll look at bottom 10%. And let's grab it. We got this bottom percentage one. All it is norm dot inverse. We need to put in the probability. So the probability that we're looking at is this 10%. I'm going to do comma. I'm going to put in the mean. And then I'm going to put in my standard error here. End parentheses, and I hit enter. And I get like 1039. And that is our answer B. Just like that. Okay, that was great. We got 2 questions down. Let's keep on going. So it says, Alex reviews a sample of 49 trading days. What is the probability that the average profit per day is less than 1,800? Okay, we have to change things now because our standard error is different now because of a new sample size. So give me just a second. We are going to insert a little bit extra space. I'm just going to insert this. I'll bring these back over here. And then I am just going to copy all of this again. Copy this. I want to paste it right here just so I can get another round in. And then I'm just going to copy all of these values, copy, and I'm going to paste them here. Okay, my X bar might not be the same, so I'm just going to kind of shift that down over here. Just move it out of the way. And on this one, I'm going to say, hey, my sample size has changed. My sample size is no longer 1. My sample size is 49. And I can hit enter, and now I have a new standard error. Fantastic. So on this one, let's look. Let's say, like, hey, Alex reviews a sample of 49 days. What's the probability that the average profit per day is less than 1,800? Okay, so let's do this one. We want a P of X bar being less than 1,800. So our X bar critical right here, let's change this, is to 1,800. At this point, we can calculate this. Let's go to our probabilities. Let's scroll over. And we look at our probabilities that we're dealing with. If we want less than a value, we can grab this area of just this norm.dist. Now, before I do that, I want to kind of come back over here and show you our distribution. I want to draw a new distribution. So this was the original distribution that we were working with. Let me, you know what, give me just a second. Let me see if I can't highlight. Can I highlight all of this? Yeah, we're going to select all of this stuff real quick. Okay, and I think I can shift this thing down. Yeah, let's shift it down. Let's grab this little line. Let's drag it down too. Okay, so that was our first distribution. Now, when we are dealing with a larger sample size, right, with the same, everything else is the same, right? The same population mean, the same population standard deviation. What happens to our distribution? Let's draw real quick to see what would happen with this new distribution. Okay, I'm going to use, let's get a different color for this one though. Let's get purple. Okay, so for this new one, what would happen is we have it coming up really high and then dropping down, because what has happened, our standard error has gotten so much smaller that our distribution has collapsed down. We are still centered on 2000 here. We can do 2, 0, 0, 0. Yep, we still got 2000, but we have a narrower distribution. And so these probabilities of these areas are going to be different now because our distribution has collapsed down. We have a smaller standard error. Our standard error here, whoopsie, sorry. Standard error here is equal to, what did we calculate? I think it was something like 107. 107. And the standard error over here, get a different color. standard error here was equal to the population standard deviation, which was equal to 750. All right, so that's what's really happened. Smaller or a narrower distribution because the standard error has collapsed down because of our sample size. Okay, let's go back and we can answer it now. So in order to calculate this one, we're going to do this area of being less than, or area to the left, and it's just going to be this norm dot dist. We need to put in our x bar that we're interested in, this 1800, comma, we need to put in the mean, which is 2000. We need to put in the standard error. Notice how we've been using the standard error labeling up here. Be sure to click on our standard error, comma, and then do true. We hit enter, we get 3.1. Now, check this out. On our questions, a lot of times what they will do too is give you an answer that if you had used this population standard deviation instead of the sampling standard deviation, the standard error, notice how it gives us this 3.949. It's like, hey, this is they gave you these two options, and this looks right because you did the calculations, but you have to remember what sample size do we have? 49, and so we need to be using the standard error here. And so make sure that you don't fall into that trap. Oh, that's question 3. Question 4, okay, again, looking at this sample of 49 days, what's the probability that the average profit per day is greater than 2,125? So now we're just looking for, let me give just a little bit of space there. I'll insert, make this just a little smaller. Okay, we're going to look for a P of X bar being, what does it say? Probability of being greater than, okay, 2125. Okay, so we're going to have like an X bar 2, just like the second one that we're working with, just for this next question, and it's 2125. And so let's do this one. So in order to do greater, we're going to go back to this one again. So we'll do equals 1 minus norm dot dist of our critical point, which is this new mean that we're interested in, this 2125. We want to be greater than it. We want the mean. We need, again, the standard error. Click on the standard error, and then true. And we hit enter, and we get 12-ish. And our answer here is letter D. Again, be careful that you don't accidentally do this population standard deviation to get 0.433. Notice, nice on this one, that wasn't one of the options, but it is a common error that I see. So go back down to our standard error. Perfect. Okay, question number 5. Alex notices that about 30% of his day tradings fall below a certain profit level. For a sample of 61 days, approximately what profit amount corresponds to the 30th percentile? It's like, okay, we've got to do yet another one of these guys. I'm just going to go ahead and insert this. And let's scroll over. And I'm just going to, let's just copy this, Control C. We will paste it here. And let's collapse that down just a little bit. Okay, so I think we've got everything that we need now, again, for this one. Now here, let's go ahead and delete out those. So we've got a new spot. We can delete out our X bars. And we can go, okay, we have a population mean, still of 2,000. We still have the population standard deviation. But now, guess what? We have a new sample size again, a sample of 61 days. Okay, let's just make that 61. And yet again, it updates our standard error. So now we want to know the lower percent. And it is 30th, so 0.3. So we want to know, kind of how we labeled it here, the bottom 10%. We want to know over here, the bottom 30%. And let's do that calculation. All right, so in order to do another bottom percentage, all we have to do is follow our guy right here. Follow this bottom percentage. If you want the top percentage, you can do this guy over here, where you just have to do 1 minus the probability, but we're up here in the bottom percentage. So let's do it again. So equals norm dot inverse. We need our probability, or this percentage that we wanted, this bottom 30%, comma, we need the mean, and we need the variance. Click on that 90, or not the variance, sorry, we need the standard error. Excuse my terminology. Standard error is the correct. We have it labeled here, standard error. We have it calculated here. Hit enter, and it's 1949, rounded up, 1950. This is our value here. Again, common issue is that instead of using the standard error there, we use the population standard deviation, and that would be 1606. And check that out. That is an option, 1607. Be sure that if you are dealing with a sample size, or always, whatever your sample size is, it's just safer to use the standard error, because if you have a sample size of 1, like we did over here, the standard error is automatically just going to revert to the population standard deviation. But in all of these other ones, our standard error is different based on our sample size. Okay, so there's a good little practice for doing a day trading example of how we can calculate out our probabilities and our quantiles using a normal distribution. Good luck, everybody.